As was mentioned in the previous video, every element has a unique number of protons. That is, the atomic number of an element determines its identity. So we want to be very certain what we mean by atomic number. So the number of protons in the nucleus of an atom is called its atomic number, and it's given the symbol uppercase Z. As atoms are electrically neutral, the number of protons is always equal to the number of electrons. And I mentioned this previously, any atom of a given type or element has the same atomic number, and every element has a unique atomic number. So what I mean by that is that carbon has its own atomic number. So carbon is atomic number 6. Then nitrogen is atomic number 7, and every atom of carbon has atomic number 6. Every carbon has atomic number 6, but no other atom has atomic number 6. Similarly, every nitrogen atom has atomic number 7, but no other kind of atom has atomic number 7. Now, the sum of the number of neutrons and protons in an atom's nucleus is called its mass number, and it's given the symbol uppercase A. Now, the reason why it's called the mass number is because it is the number of neutrons plus the number of protons. And if you recall that protons and neutrons both have a mass of about 1 AMU. So if you add together the number of protons and the number of neutrons, you get the approximate mass of the atom in AMU. Now, your book gets a little bit confused on this topic. The atomic number is always a whole number, and the mass number is always a whole number, and it is defined as the number of protons and the number of neutrons. It has to be a whole number. The number they get it confused with is something else, and we'll elaborate on that later on. Now, there are a few kind of important relationships here. The number of protons is equal to the atomic number. The number of electrons is also equal to the atomic number, and the number of neutrons is your mass number minus the atomic number. So if you think about this, the atomic number is protons and neutrons, and then we're going to subtract from that, so that's your mass number. Then we're going to subtract from that the atomic number, which is your number of protons, and then what are you left with? You're left with your number of neutrons. So these formulas can be very handy for figuring out your number of each type of particles. And of course, if we add together the number of protons plus the number of electrons plus the number of neutrons, we would get the total number of subatomic particles in our atom. Okay, so we can indicate the mass and atomic number of an element using what's often referred to as complete chemical symbol notation, or sometimes it's called isotope notation. So what we do is, before and above the element symbol, we write the mass number, and before and below the element symbol, we write the atomic number. These are always whole numbers. Okay. Now, the mass number is always bigger than the atomic number, so you always want big number on the top, and you want little number on the bottom. Okay, and then we're going to follow those numbers up with the atom symbol, so that's going to be either 1 or 2 characters. If it's 2 characters, remember that the second one is always lowercase. So here we go. This is a hydrogen that has mass number equals 2 and atomic number equals 1. This is a lithium atom, and it has mass number equals 7 and atomic number equals 3. This is a sodium atom. It has mass number equals 23 and it has atomic number equals 11. So it makes it very, very clear how many subatomic particles of each type these atoms have. Now, I should point out that there's another way of indicating what's going on with these. There's another way of writing this sort of the complete chemical symbol, and that's to do the following. And you write the name of the element, and then you put a hyphen, and you put the mass number. So you go lithium, and you put the mass number. Sodium, and you put the mass number. So that's an alternative. Okay, so it's important to recognize that when atoms interact with one another, it's going to be through their outer surfaces, and what's on the outer surface of an atom? Their electrons. So when two atoms come together, it's going to be their electrons that are going to be interacting, right? Their electrons are going to be interacting. It's not going to be the nucleus of our atoms that are interacting when these two things come together. Now, the number of electrons of an atom is determined by its atomic number. So it's not surprising that atoms with the same atomic number have exactly the same properties. That is, atoms with the same atomic number behave chemically the same. Because how do atoms interact with one another? Through their electrons, and if they have the same number of electrons, they're going to interact with other matter in the same way. So that's why when we look in the periodic table, we'll see listed in the top corner of every square on that periodic table for every element is listed the atomic number. So this is the important thing. It is the atomic number that determines the identity of an atom. When we look in the periodic table, we'll see a whole number in the corner of the periodic table, and that is the atomic number, and it's telling me two things: the number of protons in the nucleus of that atom, and also my number of electrons.